That last video on quarks, I told myself that was going to be the last video for the day, but I thought of something else, and I guess I just enjoy the sound of my own voice. So, I would like to talk about just like a thought experiment I had while thinking, attempting to understand the universe. What is the framework of time? Because I really started thinking about, like, I do a lot of thinking about space and time and the acceleration of the universe and all that. And this video is going to be dedicated kind of to that and to like a weird question I had. And it was it was bothering me so badly to the point where I made a Reddit account for the first time so that I could go on ask r slash ask science or whatever it is and post my question. And they did not answer. They didn't even let it get posted. They just they deleted it. They were just like, no, not answering this. So that's how you know it's a good question. So essentially, my thought is like, time is relative, and the relativity of time is based on two factors. It's based on the speed that something's moving relative to something else. We'll get to that because the relativity of the speed is weird. And then B is based on gravity, like how much space you're in. Because my thought on that is like the more space there is per unit of whatever measure you want to use, then the more you're actually moving per unit, let's say per foot. Because that's not arbitrary, sure. So per foot, if there's more space, then when you move that foot, you've moved more. And by that logic, it took you longer. So to start with, because I've talked about this at like bars and stuff before, but like what is the frame point for speed and relativity? Because when you travel x speed, then your perception of everything else is that it is moving at x speed. So relative to you, everything else is moving. So in like the classic experiment where it's like, I'm on Earth and I have a twin, and the twin shoots out into space and they do like a full orbit of the solar system at like close to the speed of light, and they get back in 50 years, and I'm 50 years older, and my twin is like almost same age as he left. He's looking great. Maybe a little more trimmed up than I do right now. But who is deciding that he was the one that moved more than me? Because relative to him, I'm the one moving fast. So if we both think the other one's moving, who's right? So I think that I'm religious, so you could put in the framework of God, but I don't think that's a great scientific backbone. I think that relative to space maybe would be better. And yeah, I think space moves, but for now we're just going to ground it into space as like a static thing. I don't think it is, but compared to the background space, he's the one moving at a faster speed. So he is the one that experiences time dilation. That was a whole lot of nothing to frame the question that I had. If the universe is expanding and that expansion is accelerating, then to space, everything in it is now moving faster, which means it must experience time dilation. If I experience time dilation, then that means that time has slowed down for me relative to whatever. But just because my time slows down, that's like, you got to think about this, where like time, I think, is like the speed of like electrons interacting and things like that, not so much like actual velocity. Because if something's moving really fast, then its time slow, but its velocity is still absolutely booking it, right? So I think that time might be like a percentage of the speed of light type thing, where like interactions that make up our life are based on certain movements, and that all of the movements of any matter have to average out to light speed or something like that. So like I think that like mass is made out of two waves getting wrapped together and making two particles that are vortexes, right? So some amount of that angular momentum must exist, and that the rest of whatever is left over of that angular momentum would be your velocity. And that you could probably do like math on that to figure out what like anything's true velocity is. Which is important, and I might come back to that later in this video, or never at all. Back to the question. If everything is accelerating, and then we're experiencing time dilation, does that time dilation not make it appear that the velocity of everything else around me has sped up? Because if we separate time as like an aspect of like material interactions on the electron scale versus velocity, which is like an atomic motion, the atomic velocity, then the slowing of my perception of time doesn't affect the velocity that we're moving at, per se. Like, to me, it almost seems like the acceleration of the universe could be somehow some kind of entropic force that's not affecting, like, we're like, things don't just speed up for no reason. They usually slow down. So if we separate time out, time could very easily be experiencing some force of entropy. Like, time itself could be slowing down and not everything going faster. It's like how old people all of a sudden think that kids running around are just so quick. You've slowed down. So I think that like some form of aging is going on where time is experiencing entropy and not things are speeding up and accelerating, you know? It might seem that way, but that energy isn't coming from nowhere. And we keep struggling to explain that. So that's my thought. Like, trying to figure out if I missed anything or explained that poorly, but yeah, like that is a good summary, is that like I don't think things are speeding up. I think that we might be framing the problem wrong because we're always so quick to remove time or make time the constant. And we already know that's not true. So if we look at it, I feel like it makes much more sense to say that time is slowing down, the velocity is stable, but because the velocity is the same and we're experiencing that on a different time scale, what would have been a meter per second is now 50 Brazilian years in the future. It's still 1 meter of motion, but the time that we're comparing it to is longer. So like if what was a second is now a second and a half, then what would have been a meter is now a meter and a half. But we think the time is the same, but we see the meter and a half and we're like, well, speeding up. Yeah, I think I'm done. Bye.